Alright, so here is a set of headlight buckets for that same 1925 Rio. I mean, these cars are just getting so few and far between. But let me show you what we got to do. This is our first cut. I probably should have shown you, they were pretty ugly before we stripped them and I did our first cut. But I'm going to show you a couple things. Like these, they're the headlight brackets. There's no way that we'll ever be able to get plating all underneath here. And you can see the condition, they're so rotted. As a matter of fact, you can see the inside of the bucket there. That's because this bolt was so rotted, and when they were trying to undo it, it actually split the headlight. There are a lot of stress cracks all throughout the buckets. The headlight rings, the headlight rings, this is this is when they spun them originally. It really stressed the brass to its max. You can see all the cracks. So what I'm going to do is we're going to get these, I've already ground the heads down on the rivets, center punch them. I'm going to drill those out. We're going to remove the brackets. And then I'm going to show you how to fix all these. Okay, so just completed drilling the heads of the rivets out. Over here, so that's what was underneath. All right, it had to come off. It absolutely had to come off, because anybody that tells you they can plate something like that together, they're just stealing your money. So we're going to pull out the rivets, going to sandblast these. I don't even know that these, looks like those threads might be locked up. If we have to, we'll replace. But I'm going to prep these down to a 220 grit finish now, and then you'll be able to see all the cracks and what repairs need to be completed. So I'm going to start prepping these pieces, taking all the little dings out of them. I mean, we have all over the place, they're tiny little dings. Getting them prepped, and then we'll get them down to 220 grit and show you how to fix these cracks. So you see, very soft, especially with brass, but you just want to massage this back out. What I like to do is I like to envision how the dent happened. So it looks like something came in on an angle and hit it like this, and then what I try to do is envision that same angle on the way back out. That's how you want to press it back out, the same way that it came in. And that's how you're going to have very little stretch. A lot of guys just get close and have a bunch of little lumps all over it, start grinding, next thing you know, they went through the material. So it's very important to be able to get this darn close to begin with. Alright, that one's looking pretty good. Pretty good size dent right up in here with a crack. We have to be careful with that, especially because that crack will travel if it isn't taking it out correctly. Is that annoying you? It was annoying me. Kind of really need an array of different hammers when you're doing work like this. made myself. Go out to a flea market, get some things. I want to take as little material off this as possible. Another little thing right over here. You see, I kind of just dust across this with the spinning VA because it's giving me a flat surface. As soon as I do that, I can see that I need to tap more out, not just grinding and grinding. Okay, so it looks like that one ring is ready to go to the next stage. To not bore you with details, I'll finish this up and show you when we're headed to the next stage. Okay, so maybe this will be a helpful hint for you. Hopefully you can see this. I'm here alone today, so trying to do it all. But we have a couple little things in here. This edge, obviously the light flexed at one point. So you flip it over, and I don't know, most guys probably just take a hammer and start trying to pound it, but you don't know where you're hitting. So I mean, a simple thing is, this piece is out of the strip. It's an oxidized brass. Take and just scuff it. Do not sand it, just scuff it. Piece of sandpaper, steel wool, and now you'll be able, I hope you can see it, there we go. What it does is it actually starts to reveal the head of the dent that's pushed in is now cleared and highlighted. Hold on 1 second. Let's see. Because our lighting's going off there, if this will help. If you can see it, it's a little bright. Like right here is a little head that I need to hit. And what I need to do is make sure that I'm not hitting a 1/16 of an inch over and not even hitting where the dent is, because now I didn't even play with the area that's repaired. I'm stretching the metal that's next to it and making it come out. So you can make it worse if you don't do it right. You have to be dead flat on the anvil that you're working with. If not, if you're off a little bit and you start hammering, again, you're stretching the material. You don't want to stretch the material. Just want to put it back where it belongs. And let's see if we can do this. I'm not going to do it too much because it would be wrong, but let me show you. This is, hear that tinny sound? That means I'm not laying dead on the anvil. And now you can hear the difference. That way I know I'm only able to hit down flush. Just another simple little trick. Okay, so we're gonna hit them on a 220 grit belt. Try to true everything down very carefully. You gotta be careful when you're trying to grind things on a belt like this, because if you come in and you're not hitting exactly flush, you're on the slightest little angle, that means your corner. You're gonna put ridges in your piece. So you have to be very careful. The metal finishing industry, it's truly a dying trade. But let's rip through these and then I'm gonna compound them. At that point, you're gonna be able to see all the work, all the repair work that needs to be done so much better. Okay, so quite a few hours have gone by since the last time, but you can see we have a real nice finish. I have them down to a 220 grit compound finish. It's a soft wheel so you can flow all your edges. But we're going to start talking about repairs now. And the first thing we want to do is just mark everything out, because once you start heating this and putting flux on it, you can lose a lot. So we have 1 crack, 2, 3, 4, 5. This headlight ring doesn't look horrible, but man, she got a lot of stress cracks. And they just keep coming. Alright, so the inside edge generally isn't the problem, because they take this, it's a flat piece of brass, and they actually spun these. They come to these outer corners. It's just really stressing the brass to its max, and then throughout the years it just got brittle and let go. Not only cracked, but I have a little breakthrough right on the screw hole there, so I have to fill that as well. Another one. Loaded up. Let's get the headlight buckets here. Around the plug mount. This one here runs all the way down the center of the bucket. You gotta be careful with that, because the old timers, they would try to braze this wrong. You do that, it overheats, and what it does is makes these edges just want to buckle out. And that's what's going to happen. As soon as we put some heat on here, they're going to want to buckle out, but I'm going to show you how we're going to hold that back. The brass actually wants to go back to its natural state. It wants to go back flat. It's trying to work its way. Alright, so this one's not terrible. And we may find a couple more things as we progress, but of course we got to take care of inside there, where when they were probably trying to loosen the bolt with it all rusted, it probably just popped in there and made that break. A couple stress cracks right in here. Not too bad. The buckets weren't bad. They had a lot of dents in them that had to be removed, but as far as stress cracks, not bad. But the headlight rings are a real mess. So the next thing I'm going to do is I'm going to clean up all the inside of the brass, anywhere that needs repair, and we will check back in after I get there. Okay, so we're back now. I've cleaned the whole inside edge, because we're gonna need to solder. So everything really needs to be clean. Let's talk about how this could possibly be done. I've seen a lot of guys in the business for a long time do it so many different ways, and most of them, you're doing it wrong. You know, some guys will take a file and bead that out a little bit and then solder it. You're never going to have enough strength. The solder is a soft metal. It's much softer than the brass, so there's your weak link already. It's not going to last. So what do? Some guys would say, oh, we'll put solder on the inside too. If we didn't have so many cracks and didn't have such tight tolerance, you could actually put a little hump of solder in there, and because then you're going to get some strength. If you built that up about 1/8 of an inch, we're only going to have the thickness of the material here, which is pretty darn thin if you can see that edge. So what I like to do in a situation like this is I cut down some thin brass or thin copper. What I'm going to do is I'm going to panel this in here. I'm going to put little pieces back there, pack them into place. So now the solder is not, the strength isn't between here and here. It's going to be dispersed all the way back out. You know, solder, especially if you were to just solder that there, some guys, throw it in that copper, that'll build it up. It will, and then you cut it down, you get it real nice and flat, and then you get a buffet, and the buffet is actually heating up the solder. It's going to make it drop and warp a little bit. So this is the correct way of doing it. Okay, so now I've cleaned all the inside edges so that we can get solder. Actually took a tool, ground into every crack. So now the next step is going to be trying to place our metal reinforcement and doing the decorative solder on the outside edge. But like I said, as soon as you heat this, some guys will try to braze it. Mistake. It's just going to open. As soon as you put heat, it's going to want to try to open. So if that happens, then you wind up with jagged edges all the way around. They might be minute, but they are. So what I did is I have a band that I put around the outside, which when I start to do my work, it's going to stop this from being able to expand. I can't believe I'm giving out these trade secrets because I went to the school of hard knocks and it took me a lot of years to figure that one out. Although, even if I tell you, you might not be able to do it. Anyway, we'll continue on and we're going to start soldering. Okay, so the more I play with this, the more I see more and more stress cracks. They just want to appear. You know, I could just do this for a decorative purpose. Really nice gentleman I'm working on this job for. And it could look nice for a little while, but I guarantee after vibration and things of that nature, it's going to wind up failing. So what I'm doing here, I'm taking, this is a piece of number 12 copper wire. I'm just going to pull it right back up into that little edge and then solder the whole thing around. Now that makes a ring, because if I just put some copper plate in here, my very edge, I won't have any strength there, and that's where the cracks are all going to start. So just to fix what we have here and make sure that this won't happen again, that's how I'm going to handle this. Alright, so I just finished doing this one here. That's filling in all the cracks. And of course, I got my wire soldered in. That gave this thing more strength than it was new. And the thing is, as soon as you're talking about restoration, that means nothing will ever be the same. You're never going to see the same exact problem in the same exact way. So you have to really know how to think on your feet. And, you know, it's really something new every time. Flux a little here. You want to come in with just the right heat. You don't want to overheat this and sweat the solder out from the back. Get a little bead going there, and beautiful. You see that one drop a little bit? Come through. Dropping through a bit. Just a drop more there. All right. Damn. Just you get how you like it. It bleeds through. Okay. Let that cool so it doesn't run sideways when you move. So there we are, all the way around it. I'll rinse this off with some hot water, get all the flux off it, and I'll show you the next step. Okay, so you can see where I put my slats of copper in. And that's on a really big long crack. And what that's going to do is give it the strength so that it cannot do that again. Okay, so now that we have the inside, we have the strength, the structure we're looking for. Now we're going for decorative. Good. We're going to go with real light heat. Let this fall in slowly in sections because we don't want to pop the backside where we just put that thin piece of copper. Yes, definitely an art form. So, I'm going to just try to use gravity to my favor here and run it up the hill. So maybe I'll do a third right now. Then let it cool. If not, I may lose what I put in the back. It may start to flap out a hair. Reflux a little bit, but not too much because I don't want it to trap and then start spitting back at me. Go a little bit more here. Doing probably 3 stages. Alright, so I see my solder's dropping in, giving me the strength I'm looking for. Well, I did have it hanging on an angle, and that was for a reason. I want to try to use that to my advantage. Now I'm just going to lay it down. Okay, give it time to cool. There we go. I don't want it overheated. Just trying to get all this solder to gel together real nice. So I have no air bubbles in my cracks when we go to grind this. So there's a few more areas I have to hit. I'm going to take care of them. We'll show you the next step.